Hello again. Well, following on from the last video in which we solved non-linear ordinary differential equations, at least in the last two videos anyway, which were of a similar form to the one that I've stated here, but without this um, additional term on the end. Um, I thought we would proceed to slightly more complex non-linear ordinary differential equations of this form. Now, what we do is we use a substitution again to solve this equation, and we really do exactly the same as we would have done in the previous examples. So first of all, what we do is I'm going to um, say let v equals dy by dx. Therefore, d squared y by dx squared is equal to d v by dx. Now, if you notice, if we substitute this dv by dx in to here, we'll end up with three variables. We'll have a v, an x, and a y, and we don't want three variables in an ordinary differential equation. We can only have two variables legitimately. Other than that, it becomes a partial differential equation. So we're going to rewrite this acceleration term as d squared y by dx squared. So we've got the dv here and we've got the dx there. And because there's a y coefficient, which I'll just go back to now, because there's a y coefficient there, we want to be dividing both sides by y, right? And also because we want to dy by dx there, because we know that dy by dx here is equal to v. So d squared y by dx squared is equal to v dv by dy. So there you are. Now, if we just go back to the original equation, we've got y d squared y by dx squared, which we'll rewrite as y v dv by dy. And what have we got now? Plus, well, the next term is a dy by dx all squared term. Well, we know that dy by dx from here is v. So we're going to have a plus v squared term there, minus 3v equals 0. Right, okay, well, this is now much more simplified, and we can take out a v. We can factorise out a v so that we have v times, in big brackets, y dv by dy plus v minus 3 equal to 0. Now, we've got a very basic solution, v equals 0 there, because either, we'll just write it down, either v equals 0 or, let me just go back here, or y dv by dy plus v minus 3 equals 0. They can't both be 0, but either that has to be 0 or that has to be. Now, when v is equal to 0, actually what we've got is, we know that v equals dy by dx. So, if v equals 0, then dy by dx is equal to 0, and a very basic integral solution of that is y equals a constant. Now, when v is not equal to 0, then the bit in brackets has to be equal to 0. So we'll just write that down again. So we've got y, I think we have v dv by dy. No, we don't have a v there, do we? Because we factorised it out. Right, let's just get rid of, oops. Right, let me just scroll down. So we'll just erase that. There we are. So we've got y dv by dy. I should have just copied and pasted that expression, I think. Y dv by dy plus v minus 3 plus v minus 3 equals 0. Let me double check. My memory is not always very good. And we'll just scroll down a little bit more. So we can rewrite this as, I'm going to write it here if I can fit it in, dv by dy. Yeah, let's write it on the next part of the page. Okay, so we've got y dv by dy equal to 3 minus v on the other side. So we've subtracted v from both sides and added 3 to both sides to get 3 minus v on the right hand side there. So this is hopefully not too difficult to solve. So we divide both sides by 3 minus v, put an integral sign in there, and we multiply both sides by dy and divide by both sides by y. So we get that. I'm going to make my integral signs look a little bit more realistic if I can. There we are. Right, so we've got dv over 3 minus v is equal, or the integral of dv over 3 minus v is equal to the integral of 1 over y dy. Now, you might remember from basic calculus at high school level that the left hand side integrates to give minus the logarithm of 3 minus v. And why? Well, the derivative of the numerator is just minus 1, so that comes out, hence the minus sign there, and that's equal to log of y plus, and I'm going to choose our constant, if I can stop hitting the wrong button on my pen, I'm going to choose that to be the log of a. The log of a. I ought to put modulus signs in. There we are. Not the neatest writing, I know. So what I'm going to do is now is take that -1 here and raise the 3 minus v to that -1, the power of -1, and that's equal to the log of y plus log of a. Now, if we take inverse logarithms, we get 3 minus v. I'm actually just going to put that in ordinary brackets, and that's equal to e to the log y plus log of a, right? So we've got 3 minus v. Well, actually we can write that as 1 over 3 minus v equals e to the log y times e to the log a, and so we've got 1 over 3 minus v equal to, well, e, the exponential of a logarithm of a number is just that number, or whatever it is. So in this case, that becomes y times e to the power log of a is just a, so that's equal to a y. Now we just need to do a bit more rearranging because we've not quite finished. So we've got, taking the inverse of both sides. In fact, I'm going to go back and, no, I won't go back, I won't change anything. It becomes a bit complicated if I do that. So if we take the inverse, we've got 3 minus v equals 1 over a y. That can actually just be written as, we'll call it alpha over y, where alpha equals 1 over a. It doesn't really matter what you call it. So we've got 3 minus v equals alpha over y. This means that v is equal to 3 minus alpha over y. But what is v? Well, we know that v, and I'm going to double check here, so v is equal to dy by dx in our original equation, which was up here. So we substituted v in for dy by dx, and so we've got dy by dx I'll actually make that, so v equals dy by dx, so that dy by dx is equal to, I think I've forgotten already, 3 minus alpha over y. 3 minus alpha over y. Okay. Now, what we can do here is we can multiply, multiply both sides by y. So you got dy by dx equals 3y minus alpha. Okay. And in fact, let me just simplify this a bit more, because we don't need to write it quite like that. We've got 3y minus alpha over, whoops, how's that happened? There we are. Just come down here. So 3y, let's done it again. Technical hitches. Let's right. So over y. Right, so 3 minus alpha over y just becomes 3y minus alpha all divided by y. We can cross multiply by y and dx, and we can divide both sides by 3y minus alpha. So we've got that equals the integral of dx. God, that doesn't look very healthy, does it? Let's just there we are. So there we are. Looks a little tidier, doesn't it? Therefore, how are we going to do this integral? Well, we can't write this as log 3y minus alpha because there's a y on top in the numerator of the left hand side. So it's a bit of a problem, but there is a way to deal with this, and that is let u equal 3y minus alpha. Therefore du equals 3dy, meaning that dy equals 1/3 of du. Okay, so if u equals 3y minus alpha, we also know that if u equals 3y minus alpha, then rearranging that, we've got 3y equals u plus alpha, and of course you divide both sides by 3 to get that. So we'll just delete those 3's there, meaning that we can now substitute these values or these variables into, I'll call this equation dagger. So we've got the integral of, we know that we've got the integral of y over y minus alpha, y over 3y minus alpha, oops, 3y minus alpha dy, and that's equal to, I think we said dx, didn't we? Right, so let's just double check that. Yeah. So I've just written it down there so that I can see what I'm doing. Now, we know that y there in the numerator is equal to u plus alpha over 3. So what we've got is u plus alpha, and we can take the third out of the integral sign, and that's just u d u over 3, because dy is du over 3. Yeah, I think we're all 3y minus alpha. I haven't made any mistakes. Yeah, so that's equal to the integral of dx. We can take this other third out, so we get 1 over 9 times the integral of u plus alpha over u du equal to dx. Right, now have we simplified this problem in any better way than we had before? Well, it might not look like it at first with this, but actually we have simplified it, because first of all, if we just multiply both sides by 9, we've got the du there equal to 9 dx, and then we've got this, but we can actually divide the u plus alpha out by u, so you'll be familiar. I'll just write it here. We've got u plus alpha over u, and this is equal to u over u plus alpha over u, right? Which just simplifies to 1 plus alpha over u. So we'll just erase that. We know that it's 1 plus alpha over u. We'll just go back up here. So what we've got here is 1 plus alpha over u times du. Right, okay, let's just let's just put the integral sign in there, and so we can integrate with respect to u on this side and with respect to x on this side. So we've got du plus alpha times the integral of 1 over u du equals 9 dx. Okie doke. So we've got u plus alpha log of u equals 9x plus a. We'll just call it a. Well, we'll call it a1 as a constant. Now we have to substitute back in what u actually was. So we know that u is 3y minus alpha. It's this term here in the denominator of equation dagger. So u is equal to 3y minus alpha. So we've got 3y minus alpha plus alpha log 3y minus alpha equals 9x plus a1. Now, unfortunately, y is implicit in this solution because it can't be separated out. So what we can do is we can just say that 3y plus alpha log 3y minus alpha minus alpha minus a1 equals 9x, and we don't want two constants in, so we'll just call that beta, and we have 3y plus alpha log 3y minus alpha plus beta equals 9x. I'm just going to, there wasn't much room there, I'm just going to bunch, oh, there we are. So let me see, that's beta, isn't it? Beta, let me do a better beta than that, plus beta equals 9x, and that is the general solution to the original equation, yd squared y by dx squared plus dy by dx all squared minus 3 dy by dx equals 0. And there we shall leave it for that one, but hope you've enjoyed that and got something out of it, and that you will come back and watch more of my videos on mathematics. Okay, well, thank you very much then. Bye.